Here's a tricky problem. Alice and Bob are playing a game of ping pong, but Alice is much better than Bob. On average, she scores twice as often as he does. So, to make it fair, they decide Alice has to win by 2 points, while Bob only has to win by 1 point. And that's it. Those are the rules. And there's no limit on how long the game goes. Maybe Bob wins the very first point, and then lucky him, he wins the whole game. But Alice can't do that. She needs to score at least the first and second point to win the whole game. And in theory, they could just keep alternating forever. Alice Bob, Alice Bob, Alice Bob, Alice Bob, until one of them collapses from dehydration. But that's probably pretty unlikely. So, who wins this game? Who has the advantage? Alice? Bob? Neither? Pause the video and give this problem a try if you want. Okay, well let's write down what we do know. We know that Alice scores twice as often as Bob. So in other words, the probability that Alice scores a point is 2 out of 3. And for Bob, it's 1 out of 3. Okay, but that's just the probability they win a single point, not the whole game. So how do we figure that out? Here's how we do it. We need to write down every single possibility where each player wins. Every single possible game for both Alice and Bob. Okay, so let's start with Alice. How can Alice win? Well, the simplest way would be if she immediately scored twice in a row. Remember, she needs to win by 2 points. So I'm going to denote that game by 2 capital A's. Alice scores the first point, and then Alice scores the second point. Game. Okay, but what if that doesn't happen? What if Bob scores first? Well, if Bob scores first, then Bob wins immediately, and the game is over. So I'm going to denote that game by 1 capital B, on Bob's side. Bob scores first, game. Alright, but what if Alice scores first, and then Bob scores second? Well now it's a tie, and the game keeps going. So A, B, then what? I know, Alice could score twice again. A, B, A. And then Alice wins. Yeah, that works, okay. And what if it goes A, B, B? Alice, Bob, Bob. Well then Bob wins. Put it over on Bob's side. And last of all, what if it goes A, B, A, B? Well then, it's a tie again, and the game keeps going. A, B. Then what? Hang on, it's the same thing. Either Alice scores twice in a row and wins the game, A, B, or Bob scores and he wins, A, B. Or lastly, they can alternate again, A, B, another tie, and the game continues. But now maybe you can see there's a sneaky pattern here. Maybe if I color it like this, it becomes more obvious. All of the games start with these black repeated blocks of AB, repeated over and over, until eventually, at some point, the pattern breaks, either by 2 red A's, AA, in which case Alice wins, or a single blue B, in which case Bob wins. For example, the next winning game for Alice is going to be AB. I think I said that right. And for Bob, it'll be AB. Okay, nice. This is exactly the kind of thing we can math. So, what are we trying to do again? We gotta find the probabilities of Alice or Bob winning the whole game. So at this point, we can just choose. We can choose either Alice or Bob. I'm gonna choose Alice, but rest assured, you can do this with Bob just the same. Actually, it's kind of cool to see how both of them lead to the same result. Anyway, so what is the probability that Alice is the winner? The probability that Alice is the winner is going to be the sum of the probabilities of all the ways she can win. So that's P of AA plus P of ABAA plus P of ABABAA plus ... all the way to infinity. Oh, hell yeah, infinite sum, boy, let's do it! So what's P of AA? Easy. Recall that P of A is 2 out of 3. Alice scores 2 out of 3 times against Bob. So the probability that she scores twice in a row, P of AA, that's 2 out of 3 times 2 out of 3, which equals 4 over 9. Okay. Next term, P of ABAA. Same deal, it's just multiplying. Alice scores first, that's a 2 out of 3 chance. Bob scores next, that's a 1 in 3 chance. And then Alice scores twice in a row, a 4 out of 9 chance. 2 out of 3 times 1 over 3 times 4 over 9. And for mysterious reasons with no explanation, I'm only going to multiply these first two terms, 2 out of 3 times 1 over 3, which becomes 2 out of 9. But I'm going to leave the 4 out of 9 there for now. Okay, and next we've got P of AB, AB, AA. Okay, well now this is just getting annoying. It looks scary, but it's not. It's just multiplying. 2 over 3 times 1 over 3 times 2 over 3 times 1 over 3 times 4 over 9. Okay, but once again, I'm not going to multiply everything here. I'm only going to multiply the first two pairs. One pair of 2 over 3 times 1 over 3, which is 2 over 9, and another pair of 2 over 3 times 1 over 3, which is still 2 over 9. And that just becomes 2 over 9 squared times 4 over 9. Okay, take a step back for a second. What do we have so far? 4 over 9 times 2 over 9 times 4 over 9, plus 2 over 9 squared times 4 over 9? Wait a minute. Geometric series! Yes! Wait, is it really? Wait, we better make sure. Let's just check one more term. P of AB, 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 AA, which is 2 over 3 times 1 over 3 times 2 over 3 times 1 over 3 times 2 over 3 times 1 over 3 times 4 over 9. Equals 2 over 9 cubed times 4 over 9. Yes! Yes, it's a geometric series. Okay, so first, let's factor out the 4 over 9. Then we got 4 over 9 times big bracket 1 plus 2 over 9 plus 2 over 9 squared plus 2 over 9 cubed plus ... to infinity. And 2 over 9 is less than 1, so the series converges. And of course, we all know the trick to solve this. If you don't, what are you doing? Close this video immediately and look it up. It's one of the 7 true miracles of the universe. 1 divided by 1 minus 2 over 9. Oh geez, I'm running out of space. But it's okay. In the end, it all simplifies down to 4 over 7. 4 over 7. What a funny looking fraction. Alice wins this game 4 out of 7 times, which is about 57%. And of course, that means Bob only wins 3 out of 7 games. That's 43%. Yeah, so Alice has the advantage. So, she can scam Bob and take all his money and put him in inescapable debt for the rest of his life. That's what you get, Bob, for skipping math class. I wish I had friends. There is still one more thing I want to know, though. Alice has the advantage. Okay, fine. But what if she didn't? What if the game was 50-50? How much better than Bob does Alice need to be in order to make this game fair? That's a question. Well, obviously she has to be better, so she needs to score against Bob at least half the time. But on the other hand, 2/3 of the time turns out that's too much. So it's got to be somewhere between 0.5 and 0.6666 repeating. What's a special number between 0.5 and 0.6 repeating? I'll give you to the end of this sentence to make a guess. Okay, so before Alice had a 2 out of 3 probability of scoring against Bob. But now I want to vary that. So let's change it to x. P of A equals x. And hopefully I want to try and find a way to solve for x. Okay, so P of A equals x, and that also means P of B will be 1 minus x. Yeah, and luckily for us, the next bit doesn't change. We haven't changed any rules of this game, only how much better Alice is at it than Bob. So all the games where Alice wins, or Bob wins, they're still the same. We can reuse all of that. Okay, and then there's this infinite sum for the probability that Alice wins. Yep, this is still valid. Keep going. And now we get to this part. And this we definitely do need to recalculate. Erase it all, start over. Okay, let's start with P of AA. What's P of AA? Well, before it was 2 out of 3 times 2 out of 3, because 2 out of 3 was the probability of Alice scoring. But now we've changed that probability of Alice scoring to x, so it's just x times x, which is x squared. P of AA equals x squared. Okay, next, P of ABAA. It's the same thing, just multiplying, but this time the a's become x's, and the b's become 1 minus x's. So x times 1 minus x times x squared. And then the next terms are P of AB, AB, AA, and P of AB, 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 AA. But, okay, I'm gonna skip ahead. You know the deal, you don't need to see it. It's the same thing as before. Ends up being x times 1 minus x all squared times x squared, and x times 1 minus x all cubed times x squared. Yeah, and now we've got our geometric series again. So, same thing. Factor out the x squared term, x squared times big bracket of 1 plus x times 1 minus x plus x times 1 minus x all squared plus x times 1 minus x all cubed plus dot 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 to infinity. And that becomes x squared over 1 minus x times 1 minus x. Okay, and now we want this thing to equal 1 over 2. Because remember, this is the probability that Alice is the winner. And we want to make this game fair for both players. Fair for both. So Alice and Bob should both have a 1 in 2 chance of winning. So this thing equals 1 over 2. Okay. And now we just need to solve this equation. Multiply the denominators away, expand everything, and it ends up being this nice quadratic. X squared plus x minus 1 equals 0. Okay, but it's not a nice quadratic. It's an ugly one. The two solutions to this are negative 1 plus the square root of 5 over 2, and negative 1 minus the square root of 5 over 2. And turns out that second solution is actually less than 0, but obviously all probabilities are always between 0 and 1, so fake solution, get rid of it, and the final answer is just negative 1 plus the square root of 5 all over 2, which is approximately 0.618. Yep, 0.618. It's the golden ratio. Ha, the golden ratio. Actually, technically, it's the inverse of the golden ratio, but you know, the inverse of a ratio is still the ratio. Same thing. Golden ratio. What the heck are you doing here, mate? This was supposed to be a probability video. I wasn't doing no spirals or shapes. Why are you here? You know, golden ratio is like that one guy who doesn't get invited, but still shows up every time and no one knows how. This guy. Anyway, so yeah. If Alice scored on average 61.8% of the time against Bob, then this game would be fair. They'd both win half the time. And because I can, I also ran a simulation of 20,000 games. I actually had to teach myself matplotlib from scratch, because, you know, I want to be like the big YouTubers. Blue1Brown, Numberphile, Mathologia. They all have these fancy animations and stuff, and I want it too. But I didn't even have MPL installed, so, you know, it took me a few hours of not knowing what the heck I was doing, and then eventually I pressed something and it worked! Animated 100 games perfectly. I was like, yes! And then I upscaled it to 20,000 games, and it crashed my computer. So much for that. Whatever. PowerPoint slideshow? Good enough. Please subscribe. Bye!